Good morning, students. Am I audible? Christina, am I audible? Good morning. Please ask your friends to join the class. I already texted in the group that join by 9:15. I'll start the class in a minute, okay? Let's wait for two or three more students. Should I start the class? Why so less student? Only 7. CR is present. Kavina, please ask your friends to join the class. I won't allow students after 9:20. Tell them I won't allow students after 9:20. Okay, I'm sharing my screen. Let me know if it is visible or not, okay?
In this video, we will try to understand how to draw shear force and bending moment diagram in case
Screen is
a
visible?
simply supported beam of
Audio
span
and video?
4-meter length carries and it is carrying.
Okay. So today we'll see uh, simply supported beam with point loads. Okay, we'll in few classes we'll discuss about. Uh, my voice is okay, right? Am I audible? Am I audible? Hello. Okay, okay. Thank you. So, in few these after today, from today we'll discuss shear force bending moment for different loading conditions, different support conditions. Okay. So, if you have any doubt related to shear force and bending moment diagram, please ask me during these classes. Okay. Some of you requested to do the revision, so I'll take one problem every day and we'll discuss. Okay, and later on I'll give some problems. I'll make some groups and you have to present me your answers. Okay, I'll share some theory based on this topic, shear force and bending moment diagram also. So go through those theories also. Okay, so today we'll discuss this simply supported beam with 2-point load. One is 5 kilonewton, which is at a distance of 1.5 meter. Another 7 kilonewton, and which is at a distance of 0.5 from the support. So what will be the first step? You just go through this. Then I'll discuss this problems step by step. Okay, so let's start. How many students? 23. Okay, so we can continue. So go through this problem, and at the end or at the middle I'll discuss. Okay.
Bending moment diagram in case of simply supported beam of span 4-meter length carries, and it is carrying 2-point loads of 5 kilonewton and 7 kilonewton at 1.5 meter and 3.5 meter from the left hand support respectively. So first we'll find out the reactions for this particular arrangement, which is as shown over here. So RA and RB we'll have to find out. So the first step is we'll apply the first condition of equilibrium, that is summation of forces in y direction is equal to 0. Upward forces will consider them as positive, whereas downward forces will consider them as negative. So this RA and RB, they are acting in the upward direction, so they are positive, whereas this 5 kilonewton and 7 kilonewton forces, they are acting in the downward direction, so they are considered as negative. So transfer this -5 and -7 terms on the other side, they will become positive. So 5 plus 7, that is 12 kilonewton. So let us call this equation as equation number 1. The another condition of equilibrium is summation of moments is equal to 0. We'll consider clockwise moment as positive, whereas anti-clockwise moment as negative. Now we'll take moments about point A. So these arrows, they have shown, correct, how we have calculated the moments. So suppose we start from this RB. So the arrow of this particular RB, it will go in the anti-clockwise direction towards A. So it is negative, and the perpendicular distance between B and A is 0.5 plus 2 plus 1.5. So the total span length is 4 meter. So it is minus RB into 4. So we know that the moment it is defined as force multiplied by perpendicular distance. So it is minus sign because of the anti-clockwise moment, and force is RB, that is reaction RB, and perpendicular distance between B and A is 4 meter. Then this 7 kilonewton force, the arrow of this 7 kilonewton force will produce the clockwise moment as indicated over here, and the distance between D and A is 2 plus 1.5, that is 3.5. So it is 7 multiplied by 3.5. This 5 kilonewton point load, it will also produce clockwise moment about point A, and the perpendicular distance between C and A is 1.5 meter. So it is 5 into 1.5, and that summation is equal to 0. Now transfer this negative term. So minus RB into 4 is transferred on the other side. So it will become 4 RB, and that is positive. This 7 into 3.5 plus 5 into 1.5, we have kept it as it is. So transfer this 4, which is in multiplication over here, it will come over here in the division. So we can say that 7 into 3.5 plus 5 into 1.5 divided by 4. So if you make the calculation, it is 32 divided by 4, that is 8 kilonewton. Now we can substitute this value of RB in equation 1. So from equation 1, we can say that RA is equal to, it is 12 minus RB, that is 12 minus 8, and that is nothing but 4 kilonewton. So in this way we have calculated the reactions RA and RB. Now we'll start with the shear force diagram calculations. The conventions which we have used.
So hope you have understood. The first step will be to calculate the support reactions. Okay. By using, we have three equations of equilibrium, right? Summation of x, or you can say summation of all the horizontal force equals to 0. Let take such h. Summation of v equals to 0. That means summation of all the vertical force equals to 0, and summation of movement about a point equals to 0. Right. So by using these three equilibrium equations, we have to find the support reaction. So we have 2 points here. One is A and B. Let me note once again. So we have 2 points A and B, right? So these are in, first we have to consider the sign convention for these. I'm taking upward as positive, downward as negative. Okay. So RA plus RB will be equals to, or you can say RA plus RB is equals to 5 plus 7. Right. So by taking equation 1. So this will be my equation 1. Next I'm taking equations summation of movement about 0. That means summation of all the forces of movement of summation of all the movements about point A will be equals to 0. And here I'm taking clockwise as positive, anti-clockwise as negative. So this will be my equation. This is an RB is in anti-clockwise direction. So RB into the whole distance is 4. So minus RB into 4 plus this 7 kilonewton will give positive movement. So it will be 7 into 3.5. This distance plus this 5 kilonewton will also give a positive movement. So this 5 into 1.5, that will be equals to 0. So by this equation, if you solve this, you will get RB and place the value of RB in this equation. First equation, you will get RA. So the first step of every problem in shear force and bending moment diagram to find out the external forces. Okay, that means to find out the support reactions. That will be the first step. Next step will be to determine the shear force. So let's see the next step.
RB, that is 12 minus 8, and that is nothing but 4 kilonewton. So now we'll start with the shear force diagram calculations. The conventions which we have used over here, they are upward forces, they are considered as positive, whereas downward forces, they are considered as negative. So we'll start with point A. So shear force at point A is nothing but a reaction RA which is acting in the upward direction, and as it is acting in the upward direction, it is considered as positive. So shear force at A is 4 kilonewton positive. Shear force just at the left of the C. So as there is no other force that is acting between just left of the C, so left of the C means what? We are not considering this particular point load. So 5 kilonewton we are not considering. So A and just left of C, there is no other force that is acting on the beam. So we can say that whatever is the shear force that is existing at A, the same will be existing or same will exist at point C left. Now exactly at C, there is a point load of 5 kilonewton which is acting in the downward direction. So it is 4 minus 5. So it is minus 1 kilonewton. Similarly, shear force between C and just left of the D will be the same because there is no other force that is acting between C and D left on the beam. So it is minus 1 kilonewton. But suddenly at point D, there is a downward acting force of 7 kilonewton. So it is minus 1 minus 7, that is minus 8 kilonewton. Shear force at B left will be same as that of minus 8 kilonewton because between D and just left of B, there is no other force that is acting on the beam. But exactly at point B, there is an upward acting force of 8 kilonewton. So it is minus 8 plus 8, that is 0 kilonewton. Now using these values, we have to draw the shear force diagram. So first we'll draw the baseline or a reference line. Shear force at A, it is 4 kilonewton. It will remain same up to left of the C. Exactly at C, it will decrease to minus 1 kilonewton. Then again it will remain same up to just left of D. Exactly at D, it will increase to minus 8 kilonewton, will remain same up to left of B, and then becomes 0. So in this way we can draw the shear force diagram for the given particular arrangement. Now we have indicated the various values over here.
So this will be our shear force diagram. Okay. So to find out the shear force, you have to take all the forces in upward direction and negative direction. So let's start with point from one end. Okay, you can take either this end or you can start from this end also. Okay, so let's start with this point. So at A, the shear force will be at A only one force is acting, which is upward, and that is Ra. So this will be the shear force for this point. Mark it as shear force at A. Okay, shear force will be always in load. This is the load, so unit will be always in kilonewton or newton. Okay, so at A, the shear force will be 4 kilonewton. Next, from A to C. Okay, what will be the shape of the diagram, or what will be the shape of this shear force? So let's find out the shear force at this point. That means left of C at this point. So as there is no any other loads, only one load is applying, right? Only one load is there is only one load, so it will be only 4 kilonewton. Okay, now if you consider this part, so here you will have two forces, one is upward, another is downward, right? So 4 minus 5, this is in upward direction, so it will be 4. This is in downward direction, so it will be negative. So minus 1 kilonewton. So from C to D, if you consider here also, force will be same because there is only two forces. One is upward, one is downward. So till here it will be same, minus 1 kilonewton. Now when you consider this load, there will be three loads: A, B, sorry, 1, 2, and 3. Right? So upward 4 minus 5 minus 7. So you will get minus 8. Okay. Now same, if you consider here, same this then this will be. But when you consider at B, here you have four forces: A, this, and this. So it will be equals to 0 kilonewton. So place this value in the figure. Okay, we'll get a shear force diagram. Okay, now draw this shear force diagram with the help of these values. Okay, now let's move to the movement distribution diagram.
So shear force at A is 4 kilonewton. At C left it is 4 kilonewton. Exactly at C it is minus 1. At D left it is minus 1. Exactly at D it is minus 8 kilonewton. At B left it is minus 8 kilonewton, and at B it is 0 kilonewton. Now we have to draw the bending moment diagram. The conventions which we have used for drawing the bending moment diagram, they are clockwise moments, they are considered as positive, whereas anti-clockwise moments, they are considered as negative. So we know that at the end of points of the simply supported beam, that is at A and B, the moment is 0. So bending moment at A is equal to 0 kilonewton meter, because there is no other force that is acting on the left hand side of the A, and even if we consider all the forces on the right hand side, the moment will be 0. Now the important point, we have to find out the bending moment at point C. Consider all the forces which are acting on the left hand side of C. So on the left hand side of C, there is only one force, that is Ra. So the arrow of this particular Ra, it will go in the clockwise direction towards C. So Ra is nothing but 4, and the perpendicular distance between A and C is 1.5. So as it is producing clockwise moment, it is positive, and force is nothing but reaction Ra, and perpendicular distance between A and C is 1.5. So 4 into 1.5, that is 6 kilonewton meter. Similarly, bending moment at point D, we have to consider all the forces acting on the left hand side of D. So Ra, which is acting in the upward direction, the arrow of this particular reaction will go in the clockwise direction towards point D. So Ra multiplied by, now the perpendicular distance between A and D is 1.5 plus 2, that is 3.5. So first term is 4 into 3.5. Now this 5 kilonewton force, it will produce anti-clockwise moment. So you can see the arrow of this 5 kilonewton force, it is going in the anti-clockwise direction towards D. So 5 multiplied by the perpendicular distance between C and D is 2. So it is 4 into 3.5 minus 5 into 2. So that is 4 kilonewton meter. Now bending moment at point B. is 0 because there is no other forces which are acting on the right hand side of B, or even if we consider all the forces which are acting on the left hand side of B and make the calculation, the value will come to be 0. So at the end points of simply supported beam, you can directly write down the values as 0 kilonewton meter. Now we have to draw the bending moment diagram by using these particular values. So first we'll draw the baseline. Bending moment at A is 0, at C it is 6 kilonewton meter, it decreases to 4 kilonewton meter and then reduces to 0 at end point B. So in this way we can draw the bending moment diagram in case of simply supported beam carrying point loads of 5 kilonewton and 7 kilonewton at a distance of 1.5 meter from the left hand end and 3.5 meter from the left hand support respectively. Thank you very much for watching.
So any doubt from the shear force part? So if you let's see with the bending moment calculation. Okay, so at supports, as we have discussed earlier, at supports for simply supported beam there will be no moment. So at this, as you know, your moments will be force into distance, right? So if you take a at A point there is only force, there is no distance, so the moment will be 0. Okay, next when you consider the C position, that means moment at C. Okay, at C what will be the force? This is the force acting, Ra into this distance, Ra into 1.5. Okay, next when you consider the D position, bending moment at D, bending moment D, you are taking forces from this direction. So this Ra and this 1.5 plus 2 meter, which is 3 meter. This is giving you anti clockwise direction, right? And this will give you anti-clockwise direction. That's why negative. So this 5 into 2. So minus 5 into 2. So this is the 4 kilonewton. Now at support D, your movement will be 0, right? So this will be your, place the values in diagrammatic way. So this will be your bending moment diagram. And what will be the maximum bending moment diagram? It is 6 kilonewton. So any doubts from this part? Ma'am, why we take negative 5 in bending moment at D? Because this na, wait, this you are talking about this. Okay, so see, this force and this distance is giving you clockwise movement, but this force and this distance about D, you are taking movement about D. So at D, what are the force from at D, what are the force acting? One is this Ra, this is giving you clockwise the movement, so that's why positive. This 5 will give, see, this is the force acting in the downward direction and this is the distance, so this will give you negative movement, so that's why minus. Got it, Ivan? Understood, or should I explain once? Okay, any issues from others? Good. Any issues? Any issues? Doubts? No? Orup, Atul, Christina, Fabina, Risol, Filitoli, Madhushmita, any issues, any doubts? No. I hope everyone understood. Okay. So I'll stop sharing my screen. This is so you take different loads, okay, at different points, solve these kind of problems with different loads, different at different positions at midpoint. At okay, okay. Do one thing. Let me share a screen. Okay, I'll give some problems in the next class. Okay, so write your roll numbers in the chat box for this class. In the next class, I'll give some homeworks. Okay, write your roll numbers for the first class. Don't leave the class, okay? Because I used to take the participant list also. You have to take a record of participant list also. So don't leave the class. Anyone left to write their roll number? I'll call out once, okay? Check. 109, 51, 106, 82, 84, 92, 75, 71, 74, 81, 110, 73, 67, 72, 120, 76, 101, 77, 95, 83, 99, 52, 93, 68, 63, 70, 66, 114, 12, 107 and 54. Anyone left? If CR is present, CR make groups of 4 students, 4 or 5 students. Okay, make groups and send me the names. I'll assign some work. So make a group of 4 students or 5 students and send it to me. Okay.
Ma'am, CR is absent.
Okay, so please pass this information, or you yourself make groups by yourself, okay? From only section B, a group of 4 students or group of 5 students, okay? I'll share some topics you have to make, you have to present in the class, okay? So that will be the internal marks for you all. Anyone left? Last roll number was 54. Anyone left? Okay. I'll text in the group, join for the next class. Okay. Thank you.